All right. Welcome, welcome, welcome. Game engine stream, some number above 10. I'm assuming it's 11, I'm not sure. I know last stream I said that I would not be streaming over the weekend, but I was not able to pick up a job today. So I guess I'll be streaming today. So random, hopefully rare Saturday stream, right? Let me see if I have any updates. No, I don't think I have any particular updates. I'm mostly excited about the fact that I'm ready to make Pong version 2. We have all of the setup, we have all of the tools that we need to make this new version of Pong. So yeah, I'm ready to just do this. Before I open up the progress board, let me go ahead and show you what we have from the last stream. Basically the last stream we didn't write any actual Pong code. We just got debug lines running. So now that we can basically visualize debug lines from the scripting system, and we can now do raycasts inside of the engine. Right, so we can do raycasts and we can connect that to the scripts now. So I'll show you what that looks like. Currently, it might be a bit loud. I apologize in advance. You can see on the left side, I have this little line popping up, and basically what it's doing is it's running a raycast every update. And on every update, it is throwing out a raycast from the left side all the way to the right side, and then whatever collides with the raycast in between there registers the length of the line. So with this little bit of tooling, I can show you how I'm going to use it to make the new Pong AI. So let's take a look at the roadmap really quickly. So we're going to do the Pong version 2. If we look at the diagram, we've already finished this section. This section is done. Let me get my little handy drawing tool. This section is done, right? So now we're moving on to this section. And this section looks more complicated, but essentially the new states that we're going to be working with are basically right here. So we want to be able to calculate the location of a collision with the AI's wall. And what I mean by this is basically when there is a player collision, which is the only way that we enter this state, this player collision will trigger a raycast based on the current vector of the ball. And we're going to do a while loop, which is why I had to get while loops working in my scripting, because I want to run this while loop until I either collide with the AI paddle or this wall, this right wall. Right, so basically I wanted to have these raycasts to be able to calculate this, use the while loops to go ahead and do this multiple times, and I wanted the debug line so I can see how everything's working and if it's actually making any sense or if it's just garbage code. So we'll see. So yeah, the first step is going to be just getting this working, period. The next thing will be setting up a seek location, which will be pretty easy. The only detail that I need to add to this is I need to add a location for the AI to seek. I'll probably add that in probably will be in its own component. And then once I'm able to seek a location and once I'm able to calculate these things, I'll just transition between these two states based on these collision rules. And after that point, we're pretty much done as far as I'm concerned. So yeah, that's basically a rundown of what I want to get done right now. Let me translate that into like a list of things to do, right? So instead of just create Pong AI version 2, what we really want is create calculate seek location for AI based on raycasts. And then once we calculate the seek location, we want to store seek location and store calculated location into AI component into AI entity. So we want to store that location, and then we want to seek towards that location. And create seek location states. So these are the two that we want here for Pong V2. After this, really all we have to do. Actually, I don't even need to add a new section for this. This is just gonna be finishing up the create Pong. So we'll start with these two. We'll start with this one, and we'll go from there. So let me think of where I want to start. Basically, I can just work in the engine. Actually, I don't even need to write any engine code as far as I know at this point. So let's go ahead and make a function. Yeah, we're gonna make a new function. Or a new script or whatever. Or you know what, let's not make a new script. What I want to do actually is, let me go check wherever I do the collisions, and I can start adding the logic for that. Is it ball offline collision? Is that where I handle these things? Yeah, I think it is. If collide with left wall, if collide with right wall, if collide with top wall or bottom wall, right? And then player 1, player 2, right? Player 1, we just deflect. Player 2, we just deflect, right? Right wall and left wall will end the game and increment the appropriate score. And then we clear the states. And the top and bottom wall does not impose any other logic, I believe, other than just playing a sound and deflecting the ball. Right. So let me think. I gotta think of where I want to put this function and what I want it to do. Ball offline collision. Calculate location. Dun, 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 dun. Let me go to my notes really quick. Calculate seek location. I don't know what return value, I don't know what parameters it's going to take, so I'm going to leave that open for a second. Basically, if I want to calculate seek location, the first thing I need to do is get the balls. How do I say? Get the ball's current vector And then I want to send a raycast along that vector. You know what? I'm just going to start with this. I'm just going to start with this part. Get the ball's current vector and send a raycast along the vector, and then we can just go from there. It's a good starting point. So, and I just realized this is on collision start, which I probably should rewrite at some point. Or not rewrite, but it needs to be, this whole thing needs to be cleaned up a little bit at some point, honestly. So I'll do that in a bit. But actually what we want to deal with is on collision end, because we want the vector of its direction, the ball's direction, after the collision has finished, and after we have already finished recalculating the new direction, right? So this is for adding debug points, so I don't care about this. Let me go find where here we go. So this is where I do my test line traces that I'm currently using. I'm going to go ahead and comment this out. There we go. And I'm going to go ahead and steal this code. Save this, send back over here. So basically we handled the collisions here, or basically everything past this point is just networking code. Since it basically just sends the target velocities over the network to the other player. So again, this is all networking code. I don't worry about any of this. Then actually, I can just lump all these together. Handle networking code. Okay. So here we're going to calculate AI. What are we calculating? What are we calculating here? The AI's something. Calculate AI's peak location. Okay. And now we're going to say if under the scenes, scene is scene active. And provide scenes. What is it called? I think it's just called level. Is it just level 1.kg thing? Let me go check. What's level _1.kg scene? Alright. This is incomplete if statement. There we go. So now this will only work if we're dealing with AI. Probably should get a better way to figure out the Boolean situation, but whatever. I'll probably add just like a game state thing where it tells you whether we're dealing with AI or not. That would be easier than having to check every single time about whether which scene is active. But anyways, I've been holding on to this for a second. Here we go. Okay, so we have the current entity and the other entity that we collided with. So I'm assuming in this case that the what do I say? The current entity that we're dealing with this in all cases is basically the ball. So let's see. We do still want to clear these debug lines. But the rest of this, I'm going to go ahead and comment out for a second. Because we're not actually going to use this logic. And let me go see what I put here. Get the ball's current vector, and then send a raycast along that vector. Okay, so get ball's current vector and raycast along that vector. Okay, so getting the vector is pretty easy. We're just going to go to current entity, rigid body. Yeah, get linear velocity. Yeah, I get linear velocity. And I believe this just immediately returns a vector 2. So we can just get a vector out of vector 2 out of this. Linear ball velocity. I don't know if this is normalized, so I'm probably gonna have to normalize this vector. So we're also going to need the ball's current location. So we're going to do vector 3 ball location is equal to get translation. There we go. All right. So now that we have the current vector and location, we want to send the raycast. So let's go ahead and get the actual raycast function. So we're going to do physics. And basically the raycast just takes in a two 2D vectors. Or sorry, not 2D vectors, two 2D points, right? So basically the idea that I have right now is I'm going to take the velocity, I'm going to normalize the velocity. So let me do math normalize vector 2D. Mouse is really bothering me. Oh my god. Okay, there we go. Because it clicks right when I let go of the mouse. Okay, so we normalize the vector. And then now we get the ball's velocity. And actually, let's go here for a second. Ball location. Vector 2 ball location 2D is equal to current ball location 3D dot x ball location 3D dot y. There we go. I'll fix this whole API and after I'm done with this, I'm going to come back and just take a nice big pass of this scripting system and just deal with all the things that I find very silly. So, yeah. Ball 2D locations. Okay, so now we have the ball's location in 2D, right? So we get this velocity, this vector, we normalize the vector, so now its magnitude is like, what is it? Its magnitude is 1, right? And now we want to multiply this vector, by 50. So, and it's gotta be a float because my thing does that. But okay, it multiplies the vector by 50, which now takes the magnitude and turns the magnitude into 50, if my understanding of that is correct. Is that how that works? Actually, I haven't done vector math in forever. is multiplying a 2D vector by a scalar directly modify the, what is it called, magnitude? Okay, so yeah, it directly changes the magnitude of it. Okay, so basically, if I run this code, basically I'm going to get the current linear velocity. I'm going to normalize it, so now the magnitude is 1, and then I'm going to multiply by 50, so I have a vector pointing in the direction I want, and its length is now 50. So this is what I want now. We're going to say, we're going to make one last vector, and this last vector is essentially going to be the endpoint. So ball end location, 2D. And this end location is basically going to be the ball location 2D plus ball velocity. Ball distance. I'll say raycast vector. I mean, that's more descriptive. Well, this music is going in, isn't it? Go back over this one. Okay. So ball location 2D plus raycast vector. Okay, here we go. And if you don't understand like what I'm doing, I'm gonna do a really quick demonstration of it. Basically, here, right? If we, and let me show the code. Actually, no, let me not do that. Well, let me go right here. See if I can still show most of the code without. Oh, you know what I'm gonna do? Do this. Bring this down here. And then I'm gonna bring this to a pretty regular size. Something like that. Oh, Windows. Okay, I think that's good enough. So basically, here we're getting the 3D location of the ball. That's the only way we can get the translation. I should probably get 2D translation at some point, or maybe have some like swizzling thing I can do with this API. But how do I say? Yeah, so we get the location of this ball in 3D, and then we translate it into 2D. So, and then after that we get the current vector, which in this case I'm going to assume is something like this, right? And this vector, I don't know what's normalized, so I'm going to go ahead and normalize this vector. So now its length is going to be 1. Right, and I'm going to multiply this resulting normalized vector by 50, so now I know that the length is this number times 50, so it should be a length of 50 units, right? So now I have a vector of length 50. Whoa. Let's just say this is 50. I have a vector of length 50, and that's what this raycast vector is. Then I'm going to take the ball's end location, 2D, right? Or okay, I'm going to make this final ball end location 2D. I'm going to take the current location, this point here, and I'm going to add this vector, which is going to result in this point right here. So because when you add two vectors, if I have a vector pointed here, which is essentially the position that you can think of, like the origins over here. So if this is the position, and then this is this vector, the resultant vector from adding two vectors is basically just going straight to the end, right? So now that I have this vector, I basically have the beginning and end locations of the ball. So now I can just do a raycast along that, right? So I'm going to do ball location 2D for the first part, and then ball end location 2D, and then that should give me the raycast. And then I'm gonna pull out that results as a raycast results, and then we can just pull information out of this as needed. So basically I can take this result. Well, actually, the first thing we should do, actually, it'll essentially be this code. I'm just going to copy and paste it. So if collision success from results, I'll just call it results, then I'm not going to log it. But what I will do is, how do I say? Basically, the start point is already valid in this case, but the end point is going to be the collision x, collision y, and 0.0. And then we're going to do start point, which is the ball location 2D, the initial location. And then, oh, actually, we want the 3D location in the beginning. And then we want to also draw the points as well, so it's easier to see. And the endpoint is going to be, yeah, endpoint 3. I have a 3D in this case. There we go. Okay, and this is going to occur for every collision. So instead of doing every collision, I want to check if yeah, here we go. We want to get the tag of the other one. So I'm actually just going to yank this out and bring this up here. Because yeah, I want the tag of this one. And then we're going to check if the collision is with player 1. So if we're working with the AI in general and the current collision is with player 1, then we're going to go ahead and clear all the debug lines and then redraw the debug lines. And yeah, let me go ahead and get rid of this since this was just boilerplate code. And yeah, let's see how this goes. So basically, here we just get the ball's beginning and ending vector that we're going to push into the raycast. We calculate the raycast, and then the result is going to be basically from the beginning point, wherever the beginning point was, to wherever the ending point for the raycast was supposed to be, right? So let's say that. Let's build. See if I get any issues. It's probably something I typed in there that threw that thing, but I think we're fine. There we go. Perfect. Yeah, it looks like it's actually working really well, as far as I can tell. Okay. Perfect. So yeah, now we can really visualize the collisions, right? So the next thing we want is we're actually going to use this while loop thing. So basically, let me look at my little notes over here. Okay. So we get the ball's current vector, and then we send a raycast along that vector, and now we can visualize basically where the ball is going when we finish the collision. So that's cool, right? But that's not what we want, or that's not like the end behavior that we want. So the next thing is we want to see if we're doing this whole like hitting the ball and whatever, right? We want to run a while loop. Let me see if I can scroll down a bit so it's in the middle of the screen. There we go. All right, so we're gonna run a while loop until we collide with either the left wall, the right wall, or we collide with player 2. Yeah, so these are the 3 terminal states. So you can kind of think when we're playing the game, if we do a how do I say? If we have a collision right in the game, let me pull up my diagram. So if we have a collision here in the game, there's pretty much 3 like, well, there's 5 different things. No, 6 actually, 6 different like entities that can be collided with. There's the top wall. I was gonna put T. There's T, there's bottom, there's left wall, and there's the right wall, right? And there's also this paddle and this paddle, right? Those are the only places that this ball can collide with, right? So let's think about each case, right? Basically, if we do this raycast, right, and then we collide with the paddle, then we're good. We know this is the best case scenario. It's because now we know exactly the point where we want to seek towards, and actually we're already there, so we don't even need to like move too much, right? So that's the first case. If we collide with the wall, then okay, cool, we found this location. We are going to have to walk it back to figure out this seek location, but this is still a terminal state. Like we know, like, okay, basically this is roughly the location I want to get my paddle to go towards, right? Okay. If we collide, like somehow we hit the ball in a weird way and then it collides in some way with this left wall, right? Which, as I think you saw from the last game, that is actually possible. So if that does happen, I'll just put it like here so it's not blocking the thing. Basically, we know that it's not going to hit over here and the AI doesn't need to worry about like processing a bunch of information. So it can just seek in that case, just do normal seek, right? Because basically we're already kind of at a point where we know we're going to win, right? And the only way this player is going to like fix that is if like I collide and I come back and I collide it again to try and like fix what I did. And then in that case, we're going to do a recalculation anyways. If we hit the bottom wall, right, it's just a bounce. So we just want to bounce and then just continue, right? So we want to recalculate the raycast again, essentially. And same in the same case for the top wall. So we're going to go up here and then we go, okay, this is not a terminal state. So we want to recalculate and then keep going until we hit one of these 3 terminal locations. And then I suppose there is a possibility where it hits the paddle again. So maybe I want to handle that, the player paddle. So maybe I want to handle that state as well. But in either case, the only 2 cases where I really want to use the seek location is either here when we're hitting the paddle or we're hitting the right wall, because these are the ones that this paddle needs to worry about. These other 2 states where if it collides here and then it collides here, this has nothing to do with AI. The AI can just kind of follow the location of the ball normally and just chill. So yeah, I just need to handle all those different states. All right, so let's go back to code and let's go see what we can do with that. So the first thing is I want to run a while loop, and I want to run a while loop and keep doing collisions until I reach one of these. I'm going to do player 1 as well. One of these terminal states. So let's do that. So yeah, we want to start doing a while loop. A while loop calculating terminal location of ball. Right. So we're gonna start with a while loop. I'm just gonna put true for now. I'll probably think of a good terminal how do I say, condition in a moment. I believe continue and breaks work. Okay. So let's have a check those work, so that's good. All right, so the first thing we want to do, we get the ball's current vector, right, initially, and then we get the resultant values, right? One thing I'm thinking of is maybe I can take this whole thing, and just chuck it in the while loop for now. First, this thing does not want to comply when I copy and paste it, but that's fine. And this is just gonna run forever if I leave it the way it is, so I need to deal with that. I don't believe I have switch statements yet, but I can just do like an if-else chain for now, and I'll deal with switch statements later. But basically, the first thing we do is check if there's a collision success. And actually, if there's a collision failure, we want to just break, and then maybe do like a log thing like fail to calculate AI terminal location, right? Okay, so we're running the while loop, we're getting the results, and then we're storing it in these. So instead of having these like ball 2D locations and ball end location, I'm gonna say current start location. .3D and current start location to make this more generic. Okay. Instead of okay, so raycast vector, no, this is exactly the same. What I want to call this is current end location. Three 2D. Right. So we essentially initialize the first like call, and then when we run in this while loop, we're gonna start off with a raycast, and then we're gonna handle the raycast afterwards. So the first thing is if there is a collision success, right? We output the debug line. We don't need this resulting collision entity. I don't. Oh no, actually no, we do. This is logging it. I don't care for logging it right now. But we do want the entity. And we're going to check this in a second, so I'm going to bring this down actually. So draw current raycast. Right. Oh yeah, and this is having issues because ball location 2D. Current start location 2D. Current end location 2D. Oh, because we couldn't. Oh yeah, because we couldn't parse this, right? Looking at the wrong place. Ball location 3D. Oh, okay, so this one's going to change. Yeah, this one's going to change. Vector 3 start point 3D is equal to current start location 2D dot x, and then current start location 2D dot y. And then we want a 0.0. This is just for the debug lines. And then, yeah, basically we want to start from here. And here. Let me grab this out really quick and put these together. There we go. Ball location. So this is going to be start point 3D. Start point 3D and then end point 3D. Okay. So debug line. So draw current raycast line, raycast debug line. And points. So that we can visualize it. And then here, we're going to handle the collision based on resultant type. Right. And then we'll do this if else chain based on how do I say? We'll do this if else chain based on like the frequency that I expect these collisions to occur in the game. So the first one is it's going to be like top and bottom, right? So I'm gonna need to get the tag of the how do I say? Of this entity. So string entity tag is equal to t dot tag get tag. There we go. All right. So we get the tag, and now we're going to do different logic based on what tag we get, right? So if, how do I say, collided entity tag is equal to player it's called top wall. There we go. So if the tag is equal to top wall, then we need to just repeat collision. And we're doing else if is equal to bottom wall. And then another repeat collision. Currently I want it to break. I'm gonna go ahead and break in all cases, just so I don't end up in an infinite loop. But yeah, that's just what I'm gonna do for now. Or actually, let's copy and paste this. Okay, so these are the only two cases where like we repeat the collision, and then if we collide with layer 2, then we want to how do I say, store location, peak location, and close the while loop. Okay. Okay, the other okay, so that's the first terminal state. That's the most likely like initial terminal state. The other terminal state is if we hit player 1 at some point, then we just want to follow ball location. Just set it to follow ball location, and then exit the loop. Right. And then I would say this is probably the least likely scenario. And then, again, if I get switch statements, I'll just do that and then not deal with the silliness of this. But that'll be an optimization for later. Let's see. So top wall, bottom wall, player 2, player 1. Oh, and I repeated player 1. So this one's going to be, how do you say? Left wall or right wall? Right wall is like the next most likely scenario. And in this case, if we hit the right wall, we need to walk back the we want to walk back the provided vector. Yeah, walk back the provided vector and store the seek location and close the while loop. And then if we hit the left wall, which is I think the player 1 is probably the least likely one, but the left wall is probably the next least likely scenario. In this case, we do basically the same thing as player 1. Just follow the ball and close the loop. And call it a day. That's basically it. But in all cases currently we are going to break. And you know what I'm doing? I'm gonna do maybe like a uint32 underscore t. Oh wait, no, just a uint32. Int 32, right? I might want to add static variables at some point. That might be nice. A while loop calculating term. So uint32. Max, I'll say k max iterations is 5, right? And then uint32 current iteration is 0. Yeah, I might want to have the context for or something at some point. That'd be nice. What is going on here? Forgot curly braces. Maybe it's because I don't initialize things like this in this language. I do this. Initialization lists only work for like more complex things. So then, while current iteration is less than max iterations. Yeah. I'll just do that so that no matter what, if we keep doing this, we're not going to like circle out forever. I might come back and remove that though, but we'll see. But iteration plus plus. I don't think, I don't support that, yeah. Is equal to iteration plus 1. I'm sure the compiler can figure that out. The MSVC compiler can figure that out. Oh, current iteration, that's what I called it. Current iteration. Okay. So no matter what, we won't go over max iterations. Okay. And then, yeah. So in all cases, we break here. So I'm gonna run this. Basically, this should run exactly the same as it was before, as far as I understand. Hopefully I didn't throw in a bug somewhere. Yeah, this runs exactly the same. Because we're not actually using the while loop at all. So the next thing now is we just need to repeat the calculations for the top and bottom wall. That's the first step. So draw the current raycast debug line endpoints. Basically, I want to do this. In just these two cases. So the first thing I want to do is draw collision debug line. So we'll paste it right here. Line and points, right? Okay. And then we're gonna do the same for the bottom wall. I don't know if I need to keep these information as. No, I suppose these are invariants. We'd like to know regardless, like this. I thought I fixed that at some point. I guess not. Oh. So these go not here. What am I doing? Here. Go here. Tabs, man. I really feel like just ripping out this entire text editor, but I won't. All right. Let's see. There's so many text editor bugs, it's killing me. All right. So calculate. Collision points. So calculate, what am I calculating? And brain turned off for a second. Okay, here we go. Calculate collision. Location. or maybe not calculate, maybe just store. Okay, and we only want to add a debug line in the cases of the bottom and top rows. And then this time, we just want to modify the start point. So wherever up here we have the ones we use to generate the raycast, basically we want to redo this again. So we already have like the new start location, we already have that point. Now we just need to calculate the new endpoint. So basically, current start location 2D is equal to the end, actually just collision. Point 2D. Collision point 2D. All right, so that settles that. Recalculate start and endpoint. And then we don't break this. And then we just redo the collision. And of course, this start point gets recalculated, this endpoint gets recalculated based on the current location. Okay, yeah. So we got the current start location, that's fine. Now we want to recalculate the current end location 2D. And basically, it just uses this. Now, how do I get the new direction from that point? Oh, we just use the equation I use for inversion regardless. Actually, wait, hold on. I gotta think for a second. There's a calculation I get. So the thing I'm thinking about right now is how am I gonna like calculate the inversion? Because right now I let my physics calculations handle most of the like movement, I suppose. And like the physics system just handles it. Like it does fine, right? Let me think though. raw collision debug line and point. Let me search online. Like, how do I calculate the normal and inversion? No, actually a reflection around normal. Since that day, I've lived a lie of living. My name too was a lie. My personal history, a lie. Nothing but lies. Or actually, I mean, I could, like, I mean, normal collisions, it's basically just like, you just invert the y-axis, as far as I can tell, right? So what I mean by that, let me go over here, because I think I did write like a collision thing at some point. Basically, like if you're doing like a fully inelastic collision, then when you do this collision, right? If you assume like no other like variables of like the collision, if you want it to just fully invert like this, you just the x vector component of the vector like stays exactly the same, but the y component of the vector is going down this way for this one, right? In this case, we're just inverting it to go up. That's it. So let me just try that and see if that works. I know it's probably not the exact same equation that they use in Box2D, but it might be a good approximation. So that might be good enough. So let's see. Okay, so calculate, and then we have the normal, and then we have the current like direction vector, right? Actually, it's literally just this vector, but you just invert the how do I say? You just invert the y value, because actually the magnitude's already in the correct size. So all I need to do is just invert the y-axis, now that I think about it. And actually the final calculation is essentially just going to be exactly this. So let me just come here. Let me come down here. And I'm gonna say current and location 2D is equal to current start location 2D, which fine because I just said it, right? And it's going to be equal to the raycast. I'm gonna say raycast vector is equal to raycast vector dot raycast vector dot x and raycast vector, the opposite of raycast vector dot y. Does that not work? What's going on? What if I just do this? It's literally because it doesn't like... Oh, that's funny. Okay. Wait, I have unary operators though. Wait, what are you talking about? Let me try times -1 dot. Oh no! Wait. Okay, wait, what is this? Come on. Let's see. Damn, I hope I didn't lose a lot of progress. Oh, shoot. Okay. Wait, where am I working in? Okay, looks like I saved recently. Good. Ooh, okay. So raycast vector. Raycast vector at x and -1.0f times raycast vector dot y. Okay. Ooh, that's scary. All right. Current start location 2D, collision point 2D, raycast vector is equal to raycast vector x, and you just invert the y-axis. And now we say current end location 2D is equal to basically the same calculation as before. And then this actually just becomes this. Okay, so I'm trying to build this. Okay, there we go. So it does nothing when the actual collision is supposed to be, how do I say? With anything other than the walls. There we go. Let me see if these collision paths are like actually accurate though. They're not exactly accurate. But it might also just be because of like the way I handle one of these collisions. I think I modified them a bit. But yeah, that was pretty inaccurate. Like, quite inaccurate. But yeah, I think I know why it's inaccurate. I think it's because whenever I do a collision, I mess with the vector a bit in my normal like path. So let me go see where I do that. I think it's an offline collision and the top and bottom wall. Horizontal direction, get linear velocity. All offline collision. Set velocity. Or do I not mess with it? Maybe not actually. vector. Okay. So I normalize the vector of the... So I get the current velocity, I normalize it, and I multiply it by the horizontal direction times 0.1. Okay. Because I have a horizontal, okay, so current velocity multiplied by the horizontal direction. I'm trying to understand what's going on here. So vector current velocity is equal to current entity dot rigid body dot get linear velocity. Okay, so I get current velocity. If current velocity is greater than 0, not x greater than 0, like as i.e. if we're going towards the right side, then our horizontal direction, this value is 1.0. And then if it's not, then we're going the other direction. I guess that's how I handle that. And the current velocity okay, then I set the linear velocity there prior to the collision. Play sound. And then say collision handled. Okay. Let's see. That linear velocity, current velocity, play sound, collision handled is equal to true. Okay. So it's something like this. So I'm gonna yoink this for a second, and let me head back over to where I was working on. Oh, not here. Scripting. I think it was on collision end. And let me try to mess with it a bit more to make it a bit more accurate. Yeah, it looks okay. So I forgot I can just group things and have them like that. Would have been nice to know. Okay. If current velocity is greater than 0, then get the horizontal direction of this. Otherwise, get the horizontal direction of this. And then here, and this times Things we normalize the vector and then we add it. Okay. Plus 4 horizontal direction times 0 down 1 up. Something like that, I think. Actually, I can probably take a note out of how I handled the other thing. Or how I handled it in my other code. I just did an OR. Bottom wall. Because this will calculate the direction, then we'll go ahead and invert it. And then, yeah, we can go ahead and just get rid of this. So do this. If it's right at 0, then horizontal that times. Okay, let's see if that works. It might mess it up even more, but I don't know.
People are always after the latest releases, especially people that are very into technology. They dig for the latest.
Interesting. Interesting. Looks like the bottom wall is not working for some reason. Oh, because button wall isn't a thing, yeah. Oh, no. I didn't make my own physics. Kind of just chose the battles I wanted to fight, I guess. I use a box 2D for my physics. I didn't hear you on the thing. Might be the music. Hold on. Okay. Let's try that again. Oh. Okay, there we go. It's like it's getting there, I think. A little bit off though. I'm gonna see how bad it gets. It's off by like a touch. I could see if you get like a really weird deflection pattern, it can get like way worse. I might actually want to underestimate it a bit. Yeah, I might actually want to... One thing I might do. Do this actually and just see if that kind of estimates it. It's not going to be perfect, but I don't need it to be perfect, honestly. I just need to be like somewhat in the ballpark. Yeah, it's almost there. Okay. So let's go ahead and draw this last line then for each one. Yeah, you know what? I'm gonna pull this out. Even though I just put it back in, but yeah, we'll leave that out and then we'll let them draw for all of them and then I'll just see where they're supposed to end up. Hmm. Okay. Interesting. Okay, well, you know what? Let's just go with that and see how the Pong AI does. It's a little inaccurate, but I'll go ahead and fine tune it a bit later. So now we are calculating these things. Now we can just deal with the end state. So I think the first main end state we want to deal with is which one is it? Player 2? Player 1? Okay, well, you know what? Let's do left wall and player 1 because this is actually the easiest one to. If I go to my on collision offline, I believe I have code that allows me to transition between AI states somewhere. I think it's whenever I have a collision. Oh no, wait, I don't transition states here. I actually transition states when I start the game. Now I remember now. So here we go. Yeah, so we transition to seek ball state, right? So I don't think there's anything else I have to do. Yeah, I can just do this. So nice. Let's go back to where we're at, and let's go ahead and if it's going to end up colliding with the left wall at the terminal state, and player 2. Let's see. We need to get this player 2, so we're gonna do what is it called? Entity player 2 equal to player 2. We do scenes, right? Get entity lowest, and then we do use the tag, and it's player 2. There we go. So okay, now we have player 2, and then we can set its state to seek, and then we end the loop. That's all we have to do for left wall, and for the whenever we're colliding with the player 1. Because again, here, if I take a look at this, if we collide with the left wall, whoa. Okay, maybe not that this time. If we collide with the left wall, right, or we collide with the player 1, basically the AI doesn't need to worry about this, because we know it's going to go this direction. So the AI is like, yeah, whatever, I don't care. I'm just going to seek the ball normally, and then we'll deal with whatever when it comes. The only ones where I need to worry about is if the terminal states end up here at the paddle, or if they end up on this part of the wall, right? So this is the part I need to add next, which is essentially the seek location, which the AI paddle actively attempts to move its Y value closer to a particular Y value within the bounds of the arena, right? So two things with that. The first thing is we need to set the actual location. And the second thing is we need to make the AI seek that location. So we need to add the AI state. So that's going to require adding a few things. So the first thing over here, and we're in the main gameplay. So this is the wrong one. We want to go to the other scene. Let's go to level 1. Here we go. Okay. So here we want to go to player 2. Okay. And then we're going to add a new, how do I say, a new component. All right, I'm gonna call this, I don't know. What do I call this? AI data? It's not helpful. I don't know. AI, state data. I guess I'll call it AIState data for now. I can't think of anything else. Or, no, there's a better name for this. Let's call it seek location. For now. Yeah, seek location data. That's good. And we're going to store a float location. And it's going to be a float. All right. Let's go ahead and save that. And then we're going to go ahead and add it. All right, so now we got seek location data. Currently 0, that's fine. So now we can store this data however we want. So let's go back over and we need to add an AI component now. So let's go to an AIState, create a new state. And what do I call the other one again? Let me check. Seek ball, and then this one's gonna be called seek location. Seek location. I'm testing out this thing so that it make sure it doesn't take white space. It does take white space. Don't do that. Okay, maybe I didn't fix that. I think I might have fixed that for the project components, but I didn't fix that for this. So, I guess for now I just need to remember to not do that. Everything work in progress. Okay, so on update script. So we now have a seek location state, and then we now need to add an on update for the seek location. Right. So let's add a new script too. Let's see. Seek location on update. Right, so we'll call it that. And I will fix this API later. I hate this. Actually, this whole engine probably fix it. But yeah, I think on update is just void floats. Or is it void? Hold on, let me make sure really quick. Where did I put it? Oh yeah, it gets loaded into state, and I can open it here. Oh yeah, so it takes an entity and a okay, sure. So we want seek location on update, and this is a void uint64 float. That's what it is. No group. That's fine. Also, I could probably get rid of this. This isn't necessary. This is just testing out the line trace code. But it's gonna be pretty identical to this one. Let me open up this new. I'll say current entity. And then I'll say delta time. And entity, ball, entity, seek ball. Yeah, we do need the ball for sure, yeah. No, we don't need the ball. We don't need the ball in this case, now I realize that. We just need the AI's location, which is the AI entity. Call that. Did I spell it wrong? What's happening? Oh, it's because it's not defined as an entity. There we go. Yeah, this is ball location, so this is distance, and I do a bunch of calculations based on the ball's distance. So instead of the ball, we're going to use something else. We're going to use AI entity. There we go. Seek location data. It popped up for a second, but it was gone. I think seek location data has a member called location. There we go. There we go. So now we're basing it off of the seek location data, and then we can just take this really. Let's put it right here. Let's close my parentheses. There we go. And then, yep, player 2 move up, player 2 move down. Right. Is there anything else I'm forgetting here? I think that's basically it. This is good. So now the only thing we need to do is just when we move to this location, before we move to this location, we just need to update what location we're seeking. And that's it. So, oh, and also I need to set this here. So let's go ahead and save it. All right. So now let's get this working. Let's go back to, yeah, I'm the next thing I'm going to deal with, the next step literally for Pong is cleaning up this and getting my assets in order. So don't mind the messiness. Oops. Oh my god, but yeah, it is getting messy. Ball offline collision. Is it? Oh no, it's not offline collision. It's the ball on physics collision end. Yeah, this one. So we handle it like right here, I think. Or if we collide with player 2, or if we collide with the right wall. And we will walk it back in a second, but for now, we're good. We're going to seek a location. So we want the player 2, and then we want to change its states. And the state that we're going after is seek location .AIState. And that's basically it for that. And now we just need to set the state that we want it to seek, and then we're good. So the location that we want it to seek essentially is going to be how do I say? I'll do it right here. Player 2 dot seek location data. Location is equal to and then whatever the terminal point we landed on was. That's basically what we're seeking towards. So in this case, the terminal point is going to be endpoint 3D. So endpoint 3D.y. There we go. And that's pretty much it. Now the other thing though is that whenever, so if we collide with player 1, right, then we do all this logic to figure out how we want to seek, right? And it looks like we are handling every different what is it called? Every possibility here. But the thing is, now we need to think about, okay, when we collide with anything else, what happens, right? So when we collide with the top and bottom wall, the ball goes up and hits the top wall and then bounces off. We don't want to change the AI's logic at all. The only times we want to change the AI's logic is when we collide with this pedal and then with this pedal. So we already handled the logic for colliding with this pedal, right? So now we just want to handle the logic for colliding with this pedal. So whenever we collide with the AI pedal, we just want to set the state back to just seek ball, and that's it. So basically, we can just come here. Or actually, do I want to? 15 miles an hour, dang. Okay. probably right here. I'm gonna do an if, and then this, but this time we're gonna do player 2. So if we play with player 2, then all we're gonna do is literally just this. Yeah, that's it. So now, when we collide with player 2, we just transition back to the normal seek state. And yeah, it's pretty good. Okay, so let me try that. Let me see if get any issues. I think the only thing left for this really is just to fine-tune this raycasting thing. And I think that's... Well, let me not speak too soon. There'll probably be some bugs. Oh. Well, that's fun. Yeah, that's great. We always love an assert. Is it because we were... Oh, I think I know what happened. We didn't save the scene, I think. So the assets were created, but I don't think I saved the scene, that's why. So let me head back to, what is it called? I believe I should still have all my assets for the most part. I think those save. It's just the scene didn't save. So let me head over to level 1. Or, not in the text editor. And if I go to player 2, I'm assuming I'm not going to see... Yep. Yeah. So, AIState is fine, but we don't have, what is it called? Seek data location. And then here I need to save it, because my system is kind of all over the place for that. But I believe the script should still work, so let's try that again. Okay, so it's a little inaccurate. Yeah. Well, this one's not inaccurate because of, I mean, it is inaccurate because it's a bit off, but the main reason it's messed up is because it's seeking this location instead of seeking, like this location. Let me try it again. What did I do there? That was funny. Okay, but it's kind of thinking a bit more now. Kind of cool. Yeah. See, okay, so this is an issue. It should have seeked here, but it seeked here, so that's a bug I need to fix. But I kind of already anticipated that being a thing. But otherwise, it's actually... Okay, what is that, though? What? What is that? Why do you just immediately... Interesting. Wait, why is it doing that? Okay, I'm assuming, like, 0 must be, like... Wait. Is it moving towards some point right here? Or maybe... Is the end waypoint? It was weird in that scenario. Or maybe it was using like a previous version of it or something? Yeah, it's using like an old version of it. Interesting. Oh, okay. Interesting. Interesting. Okay. So, from my understanding, let me go back over the code and reread this. So, interesting. Yeah, wait, what? Right wall and left wall. Wait, what am I doing with... Why am I... Hold on. No. This should just seek normally. Right here. This should just seek normally. And then when we hit the player 2... Yeah, for some reason we're seeking normally on player 2. That's weird. We should be seeking a location. So when we hit the right wall, this is doing all the right things, but here it's not for some reason. Yeah, store seek location. So we get the current player 2. We get its location, or we get the current endpoint location. And then we just seek towards that location for player 2. If it's top and bottom wall, we just invert the direction, run the raycast, and then just do another iteration. If we hit the right wall, that's just a... oh, well, we do need to seek the location. If we hit the left wall... What do we do with the left wall? Yeah, left wall, we just seek the ball. Okay, let me just retry this and see if it fixes the issue. It might have just been using stale data somewhere. Okay. A weird jitter thing it does is hilarious. Yeah, it doesn't freak out. It just goes to where it needs to go. That was so inaccurate. Holy crap. Okay, well, let me fix that real quick, and then I'll deal with the... Like, I'm staring at two problems at the same time. So, the first problem I need to deal with is the fact that, oh, you can kind of see what's going on here. I like that. So, basically, right, you can kind of see that it hits up here, hits down here, hits up here, right? And then the terminal state location was here, but we actually want the paddle to be somewhere around here. And we can use the paddle's current x value to kind of calculate, maybe like do like a linear interpolation to get this right here. Yeah, just use a linear equation, call it a day. How do you do algebra 1 again? Y is equal to mx plus b. What's that thing again? But yeah, we'll do something like that. The way I think about it is probably going to be, we have the start point and we have the end point. Right. And then, oh yeah, we literally are going to do like point slope. So use point slope formula to get the slope, get the line equation, and then we can just input this particular x value in here, and then we can get this terminal point, and then this is the one we push into the data. So that's fun. Algebra 1, there we go. So which one's the one to worry about with that? I think it's left wall or right wall. Yeah, then we do right wall. So yeah, we need to walk it back. So let's see. Well, no, we already have the vector, like, that goes in that direction. Yeah, where's the vector? I think we calculate it somewhere over here. Oh, no, yeah. Actually, at that point, we would have the vector just available to us in raycast vector, I think. So if we have the vector, and that vector is the slope, if we normalize it, then I think I need to use the workspace really quick to kind of gather my thoughts really quick. All right, so, okay. Y is equal to mx plus b. Let's go find that good old point slope formula. Maybe there's some way to make it easier in the code. Oh, there it is. Y minus y1 is equal to mx minus x1. And y minus y1 is equal to m times x minus x1. Algebra 1, here we go. All right. So basically, our raycast, right, is basically our slope. Yeah, rise over run. But we want to normalize it. So we want to get like a normalized vector from that. So we get the raycast, we normalize it. Norm is equal to slope, I'm assuming. Okay. Once we get the slope, right, we can basically put that directly into here, and then we can do y is equal to m x minus mx1 plus y1. Okay. And then this is our y-intercept. There we go. So we got our y-intercept. Nice little burger. Right. And then we got our slope bits and then the f of x or whatever, you know. Line, so it just counts as a function, yeah. So let me think. Just trying to think of how I can turn this into code basically. So like maybe I should think of like what I want to put in and what I want to get out. So what do I want to get out? Basically the end result that I want is I want to input a particular like y value, like, or no, I want to input an x value and get a y out of this. Yeah. I want to input an x and get a y out of this, right? So basically, I can just directly input the x right here. This will be the, I think it'll be like 0.9 or whatever x location I have for the paddle. So paddle. The AI paddle. X val. Right. So the AI paddle X val goes straight into here. The slope goes straight over here. And then this thing we can just calculate straight up like inline, I guess. So we can just do slope times x plus y1, right? And then I guess the point we can put for this calculation, and we can just choose any point, I guess. So we'll just use whatever the starting point was in that equation. So we'll just input start point. Start point. For this and this. And then of course this is the slope. So yeah, I could just write this equation and call it a day. So yeah, let's do that. Where is my thing? Where did I lose my thing? There it is. Okay, so let me just write out the math first real quick. Y is equal to mx plus x1 times m minus y1, I'm assuming. I think this is the equation I just wrote. Oh, okay, so I got the minuses and pluses switched. Okay. So this is minus, and then this is plus, and then this is like straight like this, so we're good. Okay, so now I just need to replace this with like the values I'm actually trying to set. So the y in this case is going to be this resultant location is what we're actually trying to like calculate. The m is like the normalized vector. So what we're gonna go ahead and do is do a what is this vector? Where's this vector? Where did I put it? Raycast vector. I'm gonna say vector 2 normalized raycast is equal to, and then we're just gonna do math normal. Oh, I guess it just won't let me normalize. What's it called? Normalize something. Not chatty on, by the way. Let me check. It is. Okay. Normalize vector 2D. Oh, normalize vector 2. Sure. And then we're going to get the raycast vector. Yep, there we go. So normalized vector. Maybe I'll move this down so I can check when I get errors. Okay. Actually, yeah, this is going to be an error because we don't have this. Layer 2. Actually, this is and store seek location, and then change AIState. Okay, cool. So it's equal to mx. So m is basically just going to be the normalized raycast times what is it? X. Oh, x is going to be what is it called? It's the x value of the paddle currently. So actually, since we have the paddle right here, we can just do vector 3 player 2 location is equal to layer 2 dots the rigid body. Just let me, please. There we go. Rigid body gets. Oh no, it's not rigid body. It's a transform get translation. That's what I wanted. So transform get translation. Now we're going to do player 2 dot seek location data dot location is equal to normalized raycast times x, which is player 2 location dot x minus, and then we're going to do x1, and x1 is what is it called? I believe in my little demonstration thing I said it's x1, x2 was the starting point of the array, so I believe I can just put yeah current start location 2D dot x times m, which is normalized raycast, and then plus y1, which is current start location 2D dot y. Doesn't like something I did. Float in a vector. Bro, float and vectors are fine all the time. Oh, but it results in a... Oh, okay, yeah. Oh, because this isn't a slope. What am I talking about? The slope's just supposed to be a number, but for some reason I'm applying a vector. Okay, yeah. Okay, type the slope. So slope is going to be rise over run. So that's going to be equal to... Yeah, I was wondering too. I was like, can I just multiply the... Yeah, no, what am I doing? So it's going to be raycast vector dot y divided by raycast vector dot x. And then this is garbage right here, whatever this is going on. And yeah, this is going to be a float. There we go. And then this is going to be... Actually, I'll just call it a slope, to be honest. That's probably the easiest thing. Okay, cool. Yeah, I was like, what is going on? Alright. Okay, let's try that. See if my little linear equation stuff works. I'm wondering if it's because it's like too slow, or is it... Oh yeah, it's just straight off, yeah. It's still off, huh? Wait, I think I know why. Because I'm still setting it. What am I doing here? Yeah, okay. So I set the Z location, then I set the current state. Okay, let's try that again. Because I was overwriting it. Because I'm like, it's doing the exact same thing it was doing before. I was expecting, like, if it's broken, it would just do some wacky shit. I can't tell if it's failing because it's slow or if it's because it might be... Okay, I'd like to know if it's actually because it's slow. It tried there. Yeah, it tried. Okay. So I think what I need right now is to get the pedal to actually move fast. Because right now it's moving painfully slow. So let me go check the movement code for the AI really quick. Okay, so player two move down. Right. So let me go to this function really quick. Scripts. Player two move up. Okay. So it's basing on the inputs. This is run every update, so this is gonna be interesting. Okay. I'm wondering if I want to have the speed up be its own state, or if I want to just have like a modifier that I add per state, and then like it'll automatically just speed up depending on whether it's supposed to be speeding up right now or not. I might just make it a Boolean and call it a day. Yeah, I might just make it a Boolean. So I think what I'm gonna do is I'm gonna go to my AIState. Oh, no, not my AIState. I'm gonna go to my components and open up this seek location data. Initial state? Ball state. What is initial state? Oh yeah, it's called initial state. Sure. What other components do I have? I got speed. Oh, you know what? Speed. Okay. Actually, yeah. You know what? I'm gonna store another one in here. So I'm gonna store a Boolean. I'm gonna call it. Wait, should I put it here or should I put it? Yeah. You know, I'm gonna put it here. Is fast. Is dashing, I guess. And this one's going to be a Boolean. There we go. Let's go ahead and save it. All right. And then I think in here now we should have a little, yeah, okay, it's dashing. Right? And now I'm going to say, wait, this is kind of funny actually. Wait, if I just have the code the way it is right now, I think if I hold right shift, it will make it go faster. AI faster. Let's see if that works. Okay, that was silly. I do make it go fast. That's funny. Okay, hold on. It's low-key kind of going crazy, not gonna lie. Like, okay, well, that time it messed up, but okay. Yeah, it's kind of good. I'm not gonna lie. Like, I can beat it in certain scenarios, but like, yeah, like that, like, because it kind of undercuts a little bit. But I think it undercuts because of like some stuff I did. Hold on, let me save this really quick. Let me try this again. Okay. And let me head over to not SQL. Where is it? Scripting. SQL and update. Where am I supposed to be going? Let me see. All right. I think it's here. Wherever I do this calculation, I think I put 0.2. Let me put it back to 0.1. See what's going on. It's freaking out, isn't it? Oh, that was weird. Okay, so the more I'm watching the gameplay, the more I'm thinking I can either so I can do like two things. I can do two things basically. So I could either like really try and like make this raycast thing align better with like the ball and like how it collides, right? Or another thing I could do is maybe just like once the ball moves past a certain distance, it switches over to a like seek ball essentially, right? So like when we hit it first, it'll go towards like location. Then once we're like close enough to the ball, it will switch over to okay. Now we want to hit the ball, right? And then that will like basically like whatever we do with this little like first like triple bounce thing, right? Like we can get it as accurate as like is it's gonna be, right? And then after that point, the paddle can just take over by just like following the location of the ball. Oh, and another thing I can fix real quick. I hate that jittering. I want it to stop like so much. Let me see if I can fix it. Here is, I think it's in the ball state or the location. This one, I guess it's both of them. But I'm gonna increase this like tolerance distance to 0.5, and then also for the seek on update, yeah, increase the tolerance to 0.5 as well. Let's rebuild this. I just don't know how I'm going to trigger that though, so I gotta think about that. Yeah. One thing I'm thinking about doing is maybe using like the sensors API that exists inside of Box2D, and then maybe like inside of like maybe like this region, maybe I'll have a cutoff like once we get into like this third, or maybe even like right here, where the AI can just swap from using like its approximation to just straight up just following the ball, and then that'll be it. So yeah, something like that. Let me see if it's not shaking though, or if I just mess up the whole thing. Okay, it seems like it's not shaking anymore. That's good. Totally off. The crap. Yeah, you know what? I'm gonna try the sensor thing. I think I read something about sensors in the Box2D like API. So yeah, I think I want to try it. Yeah. Okay, so let me go read the Box2D API, but I'm gonna go ahead and push the code right here. I don't think I made any actual modifications to the, yeah, I made 0 modifications to the engine. It's kind of funny. So, you know, yeah, I guess I'll just push the Pong code. The Pong code's available on my GitHub as well if you want to take a look at it, but I don't usually link it. But yeah, I think what I'm gonna do is I'm gonna add a sensors API. It might just be good to have in general. Let me go take a look into Box2D really quick. I think it's in dynamics. Yeah, dynamics. So let's go ahead and read this really quick. I'm trying to think if I would call this done for V2. You know what? I think I will call this done for V2. It's not like super polished, but like it does the thing though. It does the thing. So, and basically this game loop is already done. So basically, if you start the game and you seek, and either you do a player collision, or you do AI collision, and then a Pong collision, right? we calculate location, seek location, and then we just go back into the circle over and over again, right? Yeah, we just keep doing the circle, and then at some point someone loses the game, and then we go back to a null state, and then we go from null state back to seek, and then just repeat the whole thing back over again, right? So yeah, you know what? I'm gonna go ahead and call this done. So this is done, for sure. This is done. And this is done. So now we're going to start doing a little bit of prerequisite stuff, and I think this probably would have needed to been provided for V2 to work anyways. The whole like having like sensors available. So yeah, let's see if we can add those in from Box 2D. So wait, let me see if I can just find sensors in here. Okay, there is sensors in here somewhere. So let me see if I can find it. Gravity scale. You can scale it to adjust gravity on a single body. Be careful though, can increase stability. Okay. Complete parameters. Okay. Fixed rotation. Usually generates a sequence of images that are played at some frame rate. Whereas you can move by a large amount if a you can see objects incorrectly pass to each other. Tunneling. Uses continuous collision detection to prevent dynamic from tunneling through static lines. Is done by shapes from their old position to their new position. For new collisions during the sweep, and then computes the time of impact for these collisions. Okay, activation. Collision. Okay, user data, body factory. Okay, so they have like a whole. Oh yeah, create body, whatever. Yeah, use body, mass data, seat information is a bullet. That's cool. They have like specifically like a bullet API. I might look into that later. I think for now I might just go with like raycast bullets. While I'm just making like basic games, but yeah, having a bullet API is pretty convenient. Forces and impulses, so you can add a force, add a torque, add an angular impulse. Probably add these APIs later. Coordinate transforms, get world points, get world vector. Okay. Fixtures and joints. I think this is just talking about all the things you can deal with in fixtures. Restitution. Mix and balance, yep. Filtering allows you to prevent collision between fixtures. For example, you say you make a character that rides a bicycle, terrain, and collide with it, but you don't want the character to collide with the bicycle because they must overlap. Oh, this is an interesting API. I'll use this at some point. Okay, sensors. This is what I want. Two fixtures overlap. Yet there should not be a collision response. This is done by using sensors. A sensor is a fixture that detects collision, but does not produce a response. It is touching, begin contact, end contact. Okay, yeah, so basically, yeah, you can query like an is touching, or you can use just the standard B2 contact listener. So this works like normal, but it just doesn't place a response. But how do you set a sensor though? Static. You can flag any fixture as being a sensor. Fixtures per body, and you can have any mix of sensors, solid fixtures. Okay, so it looks like you can flag things as a sensor. So let me go see. It doesn't tell me how to do that, but it says that I can do that. So let me go look into the API and see what's up with that. Because if that's true, that actually should be pretty easy. So let me go. Let me head over here. Physics 2D service. There we go. And let's head over into wherever we do init, and we set a bunch of like information for each one. So this is on update. We want init. And here we do create. So let's go over to the constructor for B2 world, and then here we go. Register each entity. So we get a body def for each one, and then I set the custom user data for each one. And if we have a box collider, then we set the fixture data. Sure. Okay. So I'm assuming the whole sensor thing. Okay, did they say whether it was on the body or on the fixture? Two fixtures, oh, but yet they have no collision response. This is them. There's a fixture that detects collision. So you can flag any fixture as being a sensor. Okay. Sure. Okay, so this is an API set on the actual fixture itself. So if I go here, I can do fixture def dot is sensor. Oh, sick. Nice little boolean for this. So that actually will be easy. Okay. I hate these autos. Let me do ECS box collider to the component. Always confuse me. And then box collider comp. I know it's more to type, but I don't know. I can read this a lot better. There we go. ECS circle collider 2D components. There we go. Okay, so the first thing is we're going to go over this component, and we're just going to add a boolean. So we're going to say bool is sensor is equal to false. So we'll always have a default be false, right? And then we'll head over here, and then we'll do fixture def dot is sensor. It's equal to. Oh wait, I did it for the circle one, or I did it for this one, but not here. So we can store is sensor here as well. And then we set it box collider comp dot is sensor. There we go. And do that for the circle. Okay, so now we're actually setting it, which is cool. So now that we are setting it as a sensor, the next thing is we need to serialize and deserialize that information into the, how do I say? Into the scene. So we need to go to the scene manager. And then we need to go into wherever we serialize assets, and then we serialize an entity, I believe. Okay. Okay, and then we get down to wherever we do the shape components. Okay, here we go. I'm going to do out. Actually, what am I doing? This one's just going to be is sensor. Is sensor. And then here we don't have to do all this crazy mess. We just do RB2D components. This is the rigid body, isn't it? No, I don't care about the rigid body. But no, we want over here. BC2D components dot is sensor. That's what we want. BC2D component dot is sensor. There we go. And now when I open it, I can go ahead and open it, open all the scenes, go ahead and save them, and then I'll go ahead and add the deserialization code. And then once that's done, I just need to add the UI for this really quickly. The UI should be really easy. And then, yeah, basically we'll be able to modify whether something is a sensor or not. So I think in like Unreal or like Unity, this is the same thing as like having those like kind of like cube boxes where like you just check if something overlaps really quick, and then you can kind of like run some logic based on that. So this is the 2D equivalent of that essentially. Actually, let me look at the box 2D API a little more. Kind of curious what else they got. Joints, joint factory, use joints, distance joints, revolve joint, yep. Prismatic joints, specific axis. That's cool. Pulley joints. You know, I gotta go look at the those example projects they have for Box 2D. So this is called after collision detection, but before collision resolution. Okay. Contact filtering, world, exploring the world, AABB queries. Okay, cool. Okay, so let me save this scene really quick. Let me head over to the main game, level 1 scene. Go ahead and save it. Main menu. Let's go ahead and save. I don't think it's necessary for here. I just want to make sure. And now let me go back and open up the scenes text editor really quick. Just make sure that if I do have a rigid body or one of these, here we go. So we're saving is sensor right here. Cool. So now that we are saving it, we can go ahead and deserialize it. Currently everything's false, so I believe everything should still work properly. Let me check that too to make sure. But yeah, bc2d dot is sensor is equal to is sensor. This is going to be pulled in as a boolean. So this is cc2d, and this is going to be the circle collider. But everything else should be exactly the same. Now we should be pulling in this information, and since everything is not a sensor, then the collision should still all work currently as they're intended. And if that's the case, all I have to do is just go into the scene graph, make sure that I can edit these values, and then I should be good. All right, let's check this out. So if I run the game, yeah, everything is not a sensor, so we're good. Yeah, that becomes way off. Holy crap, that is way off. Oh my. Okay. I was thinking for a little bit of like a few ways to make the raycast more accurate, but yeah, whatever. Anyways, so basically, I think I just need to go into what is it called? Go into my scene editor panel. Okay. Head over to the scene hierarchy. And then we're just going to look for box 2D collider, or box collider 2D. Look for this everywhere. And everywhere we have it, I'm just going to make sure that I'm processing the right information. So initialize. Okay, so here it looks like I'm going to need an extra component. Checkbox. Check. Box collider is sensor. And then we want one more for the circle collider. We want editor UI checkbox spec. Circle collider is sensor. There we go. And let me go check somewhere else where I have like checkboxes set up, and then it's probably gonna be really similar. Alright, so it looks like for the setup, I just label it, make sure it has the correct indent, and then I just make sure it updates the correct information. Okay, that's about it. Okay, cool. So let me go to scroll down a bit to here. And at the end of this, we're going to do one for the box 2D. Box collider 2D is sensor. Is that not what it's called? Oh, I don't call it 2D. Interesting. Is sensor. Basically, we want to just, instead of a rigid body 2D, we want to get a box collider 2D components. So we want these T's here. Okay, that's fine. Is sensor what we want. Box collider 2D component. And then that's whether is treated as a sensor. Yeah. And I don't think I actually can modify the physics stuff yet. I mean, I don't really intend on things being editable like in the runtime right now. And when I do, I think I'll have like a serious pass to just like do that. So I think this is fine. That's the way it is. The way it is. I don't see wash collider. Okay, looking good. This is the circle collider, so we have put this at the bottom. Just use circle collider. Circle. Okay. Now I'm going to find box and replace it with circle. Okay, does that make sense? Check box. Okay, everything else looks fine. So we initialize it. And then let me go figure out where else I use that. This one. So we set it here. And then we use it like this. Wait, where am I using it? No, I'm confused. Edit rotation. No, it's down here. Why did it link me there? Yeah, well anyways. Yeah, so we set it every frame here, which is fine. So if you go here, basically just... Did I not copy it? That was so crazy. Alright, is sensor. M box collider 2D is sensor. And then this is the one we want to put here. Okay. And then let's head down to the circle collider, the same exact thing, except with a circle. Yep, there we go. Yeah, looks perfect. So now we should be able to edit them. Ooh, I can stand for a second. Okay. Okay. So now I believe I should be able to edit whether something has a sensor. This is a sensor. Okay, and then I can test it out. So let me go over to the next scene. Let's head over to the AI scene. This is the only place where it's actually going to be relevant. And we're going to add a new entity. I'm going to add a new entity forever. I'm going to call this entity, what is it? AI player to proximity sensor. And let's figure out where this thing is. It's over here, I think. Let's move it. And I'm going to give it a box collider. Let me give it a rigid body as well. And let me give it a box collider. Okay. This one's gonna be static, of course. Fixed rotations, stay where it's at, sure. On physics collision start, on physics collision end, yeah, we will have some logic for sure. Alright, and then we're just going to scale it a bit. Go to like 25, I think. And then we're going to scale it maybe like 40. And that's too much. 30? 35? 32? 31? Yeah, 31 looks good. Yeah, I like 31. Let's move it over a bit. Yeah, that's alright. Let me make it a bit less wide. I'm gonna do 20. Let's bring it over. Yeah, do I want it to start following? Let's go like 15. Alright, let's take a look at how that looks. So yeah, sensor is pretty much picking up this space. That's good. Alright, so we have set a sensor. Let's go ahead and save this. Let's try to just run it. Hopefully it just won't collide. Yeah, it's not doing anything good. Oh, but it's... okay. Okay, so I want it to ignore the sensor. So, gotta figure out a way to get it to ignore the sensor, you know. Let me see. Okay, I think I have an idea. So let me go over to wherever it is logic for handling this raycast, which I think is in scripting on collision end, right? And if we do this, Now go here. I'll say else if collided entity tag is equal to player to proximity sensor. Player to proximity sensor. So if it's equal to player, then we just want to like have it continue going, right? So basically the start point is equal to the current location. Oh, okay, so basically we, at this point in the collision, we basically have this right here, right? And I think what we want is just to keep going. So we don't need any of this really. We just need to like reset these things. We don't need to do any of this calculation like garbage or whatever. We just say the current location now just becomes the whatever the collision result is. Collision points 2D. And then just continue. Because we'll set this beginning point now to here, and the original like overblown vector that I start off with is still over here, so I'm just going to continue going. There's probably some other way to like logically ignore these things, and I'll probably add that at some point. Actually, hold on, let me see if there's like a better way to do this. Is there a way to ignore sensors? Box to the raycast. Yes, you can effectively ignore sensors when performing ray by setting collision match to 0. This essentially makes the raycast as it won't register any collisions with the ray, even if it overlaps with it. Okay. Sensors collision filter. Sensor I'll give you what I've completely rely on another piece of code to actually work. Okay. Yeah, there's got to be a way to like set it so it just completely ignores it. I think this should work though. I forgot if I recompiled it. Let me recompile it again. Yeah, so it collides with it and then just continues on like nothing happened, essentially. Yeah, I don't particularly love that though. I'm gonna be completely honest. Let me go look at the API really quick. Maybe there's something I can use in there. But really quick, I'm gonna use the restroom and I'll be right back. Okay. So, got our little raycast system going, kind of. But yeah, I was looking at the Stack Overflow post about someone talking about this situation where we want to ignore sensors. Oh, someone has a tutorial on here. Let me take a look. In the previous topic, we said that something. Okay. This one friendly. Near a radar sensor. Interesting. A radar sensor. A semicircle. It's in the angular will be okay. You find the raycast callback. Raycast. Okay, interesting. So yeah, there appears to be like a very specific way to like set this up so that certain things can only collide with certain other things. Yeah, I definitely am gonna want to like read into this at some point and really understand what's meant. Because they have a whole system of like they have like a bit field type of deal they got going on. Which is cool for like determining whether certain fixtures should collide or not collide with other fixtures. So yeah, that's interesting. Huh. Wait, ignore raycast. Is there sure like an ignore raycast in Box 2D? Hold on. Maybe that's a Unity thing. Let me see. Well, ignore. Is that ignore? Yeah, let me go down to the raycast API. See. Let's see what they say. Maybe they have a little section about like dealing with weird scenarios in raycasts. Raycast by implementing a callback, the world class is fixture hit. Callbacks right with picture. They you cannot make assumptions. You control action training of action 0 in case the race should be terminated. Reshape, recast all shapes. So you can recast any shape, recast all shapes, or recast the closest shape by returning their appropriate fraction. Due to random errors can sneak through small. Maybe they have a section just on raycast somewhere. Box 2D raycast. Okay, this guy has like a tutorial. Let me see. On raycast. two raycast outputs of each other. For clarity, delete the first one and you should get this result. Maybe ChatGPT knows. I don't know. Let's see. How do I ignore a sensor using a raycast with box 2D? Actually, it doesn't cause collision, but it can still trigger events. It's just if you want to ignore a sensor in raycast using a custom raycast callback, here's a general approach. Create a custom raycast callback. Box 2D will let you define a custom callback to control which fixtures the raycast interacts with. Skip the fixtures that are sensitive. Oh, yeah. Okay, that's yeah. I figured that was it, but all right. So okay. So for now, until I want to like expand this API more, I'm just gonna assume that if I am having something as a fixture, like as a sensor, then I don't want it to interact with the raycast. So if that's the case, let me go to my engine code really quick. Let me go to wherever I do raycasts. Can you take me there or like? Oh, maybe we're already here. That's why. And then I think I implement it somewhere in here. Yeah, this one. So I'll say we return it. Oh wait, no. This isn't the actual raycast. So the actual raycast limitations right here. So here I'm going to say if fixture is sensor. Skip all sensors or raycasts. That's it over here. I'm gonna save whatever I've done so far, just in case. Okay, and now I believe my raycast should just implicitly ignore sensors. What did I do? Oh god. Oh, because I tried to like actually use the fixture here, and I'm assuming it's not defined here. It is defined here. V2 fixture. Oh, I guess it's not defined. Okay. I suppose I could let's cancel this and just take this whole implementation out of the header file. Yeah, because it's a pointer, so it doesn't need to. Okay, well, I guess that was the first time it was actually used, so I guess that makes sense. Okay, let's try that. Is my Chrome? Oh, I made it. Oh, there we go. All right, take a break really quick. I'll be right back. All right, I am back. Let's see if this raycast thing like figured it out. So I should just be able to run it. Let's see. Okay, yeah, it's just straight up ignoring it. Good. Okay. So all right. So we just need to add a little bit more logic when we do an on collision end. So let's see. On collision. So if we collide with player 1, we do some stuff, right? If we collide with player 2, we do some stuff. And then now if we collide with he who will be named, they who will be named, what is it called? I don't know their name. Let me go to that scene. Yeah, this, whatever this is. So player to proximity sensor. There we go. And I'll say transition to seek the ball once within range. And you know what? I probably don't want to do this at the end of the collision, now that I think about it. Probably want to do this at the beginning of the collision. So let me link this out. Close this for a second. Let's head over to on this collision. So it decides whether we do offline or online collision. So yeah, I'm gonna go ahead and do offline collision. Suppose I'll just do this here. I don't know. Step. Oh, just do this then. We just set it to seek ball. Okay, here we go. So now basically whenever we start a collision or start an overlap with that section, it's just going to start seeking the ball. And again, this is about yay big, right? So if we're getting to the point where like we're pretty much here, it should directly just start seeking the ball. So let's go ahead and try that. Oh wow. Wait, actually that works. Holy crap. It's kind of funny transitioning. Yeah, for sure, man. Appreciate it. Let me see. So I don't have much on my Discord. Let me see if I can open it really quick. Sure, yeah. All right. Gentlemen, yeah, I appreciate it. Let me see. This is actually working. Holy crap. I'm just amazed right now. Maybe I should move it back a bit. I'm on the last minute adjustments. Okay, hold on, hold on. I'm gonna be right back. I'm gonna be right back, about 5 minutes or so. All right, I'm back. Sorry, I was talking to someone. So, let's see. So yeah, I think at this point, I mean, it's not perfect, you know. I mean, again, I could probably make the deflection algorithm a bit better. Maybe like actually use some of the more like box 2D things, or maybe make some better approximations for it. But as far as like just playing against it, it's actually pretty fun, I'm not gonna lie. Yeah, like it really does think. Like you really gotta confuse it to like beat it. Yeah, that's cool. I like that. So yeah, I think that's version 2 done actually. I think it's been done for a minute, but I think I really want to get this little sensor thing in, so that how do I say? I don't know. It's a bit more difficult to beat, you know, and I think it's a pretty good challenge at this point. So let me go look at my list. Where's my list? All right, so yeah, I mean, Pong V2 has been done for like a minute, honestly. Yeah, Pong V3 and then Pong V4 is basically the last steps for this. And I don't, if I need to add new engine functions to get it to work, I will add them in. But I don't anticipate needing any new engine features to get these to work. Especially this one. We're pretty much good at this point. So let me see. I guess I'll go ahead and push the code really quick. I'll go ahead and put what I changed. Set whether box collider is treated as a sensor. So add support for treating box colliders and circle colliders as what are they called? Sensors. What else? I added a few things, I think. In engine components.h serialize / deserialize is sensor boolean for box / circle colliders in scene manager.cpp. What else did I change? Let's go ahead and put also and scene editor handle that /h. That's mainly what I did there. And then here I added a few things, I believe. Yeah, I mean, that was mainly it. Just add sensor support to engine. Add sensor support through in editor and engine for colliders. Physics colliders. All right. So that is, I'll go ahead and push that later. Let me see what else so I don't forget. All right. So yeah, the progress report's been updated. I'm thinking about streaming later today. I'll see. I'm gonna go ahead and edit this video and post it on YouTube. And then, yeah, I'll go ahead and see at that point. But yeah. All right. I'll see you guys later if you're on YouTube. I hope you have a good day. Later.